All right, this is our second set of notes for the unit. Set notation. And notation is just a word we use when we talk about the symbols that represent some kind of idea or concept. And the word set means a group of things, like we talked about groups of numbers in the last lesson, natural numbers, whole numbers, all those kinds of things, those are sets. And we'll be talking about how you can you can talk about only one thing from that set, which we would call an element. And we're going to talk about how you can consider small groups of a larger group, which we call subsets, and how these symbols here can be used to write that information down. So don't worry about all these words right here. I'm about to talk about all that as we fill out this table. So let's say, for example, in words, I wanted to say that 5 is a natural. That was a fair amount of writing. In math symbols, we could just do this. The concept of 5, we have a symbol for that that looks like this. And then we've learned this symbol for natural numbers. And for the part of that, with the words that we did where it says is a, I'm going to put this. And if you were to actually read that symbol out loud, it actually is read is an element of. So these symbols I put here really would be read like this. 5 is an element of natural numbers. And similarly, if you wanted to say 5 was not an element of something, so for example, if we wanted to say 5 is not an element of the irrational numbers, for example. We would write the 5 and then we would write the n, and we would write that same symbol, but we would put a cross through it like that. 5 is not an element of the natural numbers. And in these two cases right here, when we use that symbol, this E, that's when we're talking about a single thing from a set, as opposed to many things, which would be a group. And that's what we're going to talk about now if we're talking about groups that belong to bigger groups. So let's say we were trying to say that the natural numbers are a subset of real numbers. Subset means a group that's contained entirely in a bigger group. So for example, if you think about Johnson students, I could say that the ninth graders are a subset of the entire student body, right? The entire student body is actually made up of 4 groups: freshmen, sophomores, juniors, seniors. Each one of those is contained entirely inside the bigger group. So I would say the freshmen are a subset of the Johnson population. Or I could say the natural numbers are a subset of the real numbers. And this is the symbols I would use for that. The natural numbers, the real numbers, and this symbol means is a subset of. And just like for above, where I could say is an element of, and I could say is not an element of, I can do the same thing with this one. I could say something is not a subset of something else. So if I were to say that integers are not a subset of whole numbers, I would write this. The funky Z for integers and whole numbers, the funky W, and I put that symbol with the cross through it. The integers are not a subset of whole numbers. And this is what we use when we're talking about groups or subsets. So the first two examples were single elements from a set. The second two examples were smaller sets that belong to bigger sets. Sometimes we can have a set that's made up of single elements. So for example, if I wanted to write in set notation, the set of the first 4 even natural numbers, I would use these are called curly braces or brackets. I also like to call them squiggly wigglies because this is what we use for set notation, and both set and squiggly start with the same sound. So we'll use our squiggly wigglies, and it would look like this. The set of the first 4 even natural numbers would be 2, 4, 6, 8. And so this would be considered a group. So we would use the subset notation, the flattened looking C that we did in the red examples, if we were trying to say that was a subset of something else. So those are the symbols. We're about to do some practice problems with those. I want you to pause your video and just read. This is the bottom left section of your notes. I want you to just read it, annotate the things that it's asking you to think about, and then come back when you're ready to hear what I have to say about it. This section says, list the set of natural numbers that are, and then it gives 3 different examples. And these examples do not build on each other. They're separate. So we're going to do those one at a time and then move on to the next one without thinking that we have to include the other one as well. So the directions say, list the set of natural numbers that are these things. Now our answers would change if this was a different set of numbers. So we have to be sure we understand what the natural numbers are. So as a review, it's 1, 2, 3, and so on. So I want you to pause your video and think about what kind of natural numbers are negative. You should have maybe been a little bit stumped on that one, even for just a moment, because there are no negative numbers. And that wasn't necessarily to trick you so much as I wanted it to come up for you in an organic way so that I could then tell you how to handle set notation in this situation. We're still going to use our squigglies. And then we're going to put nothing inside there. This is what we call the empty set. You might see this also sometimes called the null, N-U-L-L set. You may have also seen this used when solving systems of inequalities that have no solution. It can also mean no solution. And leaving it empty is different from putting a 0 in there. 0 is a quantity or a number, and it's like, 3 minus 3 is 0. And that's not the thing that we're talking about here. We're actually talking about nothing. There's no solution. There's no thing that is an answer for that. If I put 0, I'm kind of saying that is the thing, that is the answer, but there's no answer. So it's just empty. So pause your video and try example 2. Now, if for example 2, you might have thought, okay, greater than 100 natural numbers. If you started with 100 as the first thing, you were going too fast, because it says we want the first natural number that's greater than 100, and that's 101. And if after that you thought, oh, well, there's infinitely many numbers, and I am not listing all those numbers, and you decided to do ... Well, I'm not really happy with that either. Here's what I will, because there's no pattern. Like, I don't know if you mean 101, 111, 121, 131, because you're skipping by tens, or maybe you were trying to say 101, 103, 105 because you were doing odds. In my classroom, for best practice, I want you to use 3 numbers to set a pattern before you do a dot, dot, dot. So in this case, that would be 101, 102, 103, dot, dot, dot. And I'm happy with that. All right, so then pause your video and try example 3. All right, on this example, there's a couple things going on. If you were going really fast, you might think 5 is the lower number and 12 is the upper number for your answer. But I want you to be a little more careful when you're reading. There's a couple things going on. It says, the first part says we want the natural number that's greater than or equal to 5. That means it includes 5. So when we start our squiggly wigglies, we can start with 5. And then the next natural number after that is 6, and then 7, and so forth. But it will not include 12 because it says and less than 12. It does not say can be equal to 12. So we are going to stop there at 11. Unless you wanted to use your dot, 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 and you used 3 numbers for your pattern, and then went to 11. Okay. So that section was practicing with the squiggly wiggly notation. In this next section, we're going to be practicing with the subset notation. But I want you to take some notes first. On my printed notes, what I'm about to draw, I put right here on the sort of right half of that section of your notes. We're going to be doing kind of like what I like to call a family tree of numbers. That's not what I'll try to fit it in here. It's the right kind of small. In the last lesson, when we first talked about the different classes of numbers, we started with the natural numbers. And that was the smallest group. That was 1, 2, 3, and so forth. And then we added 0 to that group, and it got a little bit bigger. And we called that whole numbers. And then we added can already tell me this one. And then we added negative numbers. Stop it. Okay. Negative numbers and called that group integers. We added partial numbers and said anything that can be a fraction is next, and we called those rational. And we said if it couldn't be rational, it had to be irrational. And that was just another whole separate group by itself with no overlap with any of those on the left. And when we combined the rational and the irrational, we got one huge group called the reals. Now, when I'm trying to determine subsets of something and write it in symbols, the subset goes on the left and the larger set goes on the right. So I could say, for example, that the natural numbers are a subset of the whole numbers. And I could say also that the natural numbers are a subset of the rational numbers, because every single natural number is also rational. It's in that group. Every single natural number is also a whole number. It's in that group. And if you notice that N on this family tree is below the Q and it's below the W. So anytime you're trying to write a statement with the notation using the subset notation, anything from the bottom is going to be a subset of stuff above it. So even if I didn't want to do an example with N, if I wanted to do an example with W, with the whole numbers, it's a subset of anything above it, the Z, the Q, or the R. So I'm just going to put Q here. So anything going up uses this subset of. You're starting at the bottom and going to the top. And the opposite is true if you're going down. If you're starting with a group up top and trying to understand if it's a subset going down, it would not. I would say is not a subset of. So for example, if the thing I'm writing on the left of my statement is the real numbers, it is not a subset of anything below it. So it would not be a subset of the whole numbers, for example. And the integers would not be a subset of anything below them, like the natural numbers. So I want you to take a minute on those examples right there and to say if they're true or false. And if you've decided one of them is false, you need to state why. So pause your video and try that. All right, here's what I'm hoping you got on those answers. Number 1 is false. So it says Z is not a subset of R, but we can tell by our number tree that it is because it's below R. Every integer is also a real number, so it's a subset of that group. So we could say false because all integers are real, for example. Number 2, I hope you got true. It's absolutely true that the rationals are a subset of the reals. And number 3 is false, and I'll give a counterexample for that one. You just need one counterexample. So it's false because, for example, 5 is a real number, but 5 is not an irrational number. So if you can find even one example of the real that doesn't belong to the irrational, then it can't be true that the reals are a subset of the irrational. Because a subset means everything inside the subset belongs also to the bigger set. Right? Hopefully you got those. And then this last part of the notes, identify each of the following as true or false. Again, if false, state why. So pause your video and try that before you come back. Right, hopefully you got false on all of these. Example 1, false, because no negative numbers are natural or are in the natural numbers or something like that. Or false because there are no negative natural numbers. Number 2 is false. It says 2/3 is not rational, but it absolutely is, right? It passes the fraction test. So you can say false because 2/3 is a fraction. I'm okay with a simple answer like that. A better answer, more technical answer would be because 2/3 is a fraction and all fractions are rational, or all fractions belong to the rational numbers or something like that. And there's a typo here. I'm so sorry I didn't tell you before you paused the video. I don't want that to be an element. I want that to be subset symbol. I'm so sorry. Pause your video if you want to rethink about that problem now. So this one fails. It's a little bit confusing. So in order for this is a set of elements, and altogether it makes a group, right? So we want to know if it's a subset of the integers. And some of them are integers. 2 and 3 are integers, but the other 2 fail. 5/2 and 7/2 are not, because integers are positive and negative whole numbers. 5/2 and 7/2 are fractions. And it really only has to fail in one place for this to be false. It fails in 2 places, but when we say our answer, we only need to use at least one. You can use both, but it's sufficient to just use one. So I could say just false because 5/2 is a fraction. If I wanted to do that even better, I'd say is a fraction and no fractions are integers. And that's it.